Do you look at the booklet? Take a look. All right, so let's get started. So the page that I just gave you is a review, my review of SOHCAHTOA. Okay, so here is a summary. We can, if you want, read through it, but I just walked you through the one pager. If you want to practice basic SOHCAHTOA, on the back of the page that I gave you, there are practice questions. Okay, but you might not need that. So let's look at example 1. Okay, example 1 says, what does it tell us to do? It says solve the right triangle. Okay, do you know what that means? Not just, what is it? That's right. Find all the unknowns. When we say solve an equation, it means find the value of x, but x is called an unknown, something we don't know. So when they say solve an equation, it means find all the possible values of x. So when they say solve a triangle, they're saying find all the things we don't know. All right, so that means we must find the two angles the two sides and one angle. Okay, we are told to only use trigonometric ratios. Okay, someone is going to be tempted to use Pythagorean theorem, Liam, but you're not allowed to use the Pythagorean theorem because we're practicing using the trig ratios. Round to one decimal place and recall, to solve a triangle, it means to determine the lengths of all sides and angles. All right, so in this case, folks, my O, A, and H might change, but let's start with what we've got. I've got this angle, okay? I've got this side. How many pieces of information do I have about this triangle? What are the four? Well, no. How many pieces of information are given? 3. I know. You can deduce, you can easily calculate the angle C, but we are given 3 pieces of information, and this is important. You can only solve a triangle if you have a minimum of 3 pieces of information. So once we start sticking multiple triangles together, you're going to need to figure out which one do I solve first. You need to have 3 pieces of information, and we do. We have the length of the hypotenuse, we have this angle, and we have the 90-degree angle. The 90-degree angle tells us we can use SOHCAHTOA. So let's start off by labeling the triangle as OAH based on 18.6, right? This is the angle that's given to us. This is the hypotenuse. That's the opposite, and that is the adjacent. In step 1, I know Luke is very keen to solve for angle C. Okay, let's figure out what is angle C. And now angle C, we can use the sum of angles rules. Sum of angles in a triangle equals to 180, right? We call that the sum of angles. All right, so that means that angle C equals to 180 minus the other angles, minus 90 minus 18.6 degrees. Okay, go ahead, calculate that. We're told to leave our answers with one decimal place. Okay, do you have a question? Okay. All right, what's that give us? 71.4 degrees. Great. All right, step 2. Let's solve for, do we want to solve for A or C first? Let's solve for C. All right. So in step 2, so we want to find out what is side C. So we circle what we have. We know the hypotenuse, we know the angle, and we circle what we need, which is the adjacent side. In that case, am I using so, ka, or toa? This is a case for ka. And so I write the formula cos. Now, which angle do I use? The one that I circled, right? Cos 18.6 degrees equals adjacent, which is just labeled as letter C, over the length of hypotenuse. What do I do to both sides? That's right. I just multiplied by 11.3. All right, go ahead, solve. And can someone give me the answer once they got there? 10.7? Thank you. Incomplete? Centimeters, thank you. Okay, let's just be careful with the, oh yeah, and that's, thank you, great point, Marley. It's approximately 10.7 centimeters, right? So let's just put that dot in there. Kashi, can you see? Okay. Okay, and what is left to solve? Well, what's left to solve is side A. Now, in side A, I'm not circling this one anymore, right? Because now my unknown is this one. So which ratio should I use? Pardon? Nope. Watch here. You could use tan. Right. This is, okay. We're going to try to use the original values given. Why would you not want to use this one, Sebastian? That's right, because you've already cut off some information, right? This is an approximate value that you've calculated. So if possible, we stick with the original numbers. So I'm going to use H and O, meaning that I'm going to use the sine ratio, right? This is a case for so. And we'll write that sine of 18.6 degrees equals A over 11.3. Multiply both sides by 11.3. 3.6. You done, Luke? Come on. Nice. And what else? What did I miss? Approximate. Beautiful. All right. Last thing I want you to do is make a list. Right now that we solved, our information is everywhere. Organize. Make a list of the 3 things that we found.
For this question, can I have another 800? Does have to be different.
You can. It's just any one transformation. Any one transformation. All right. And so I'll say, therefore, angle C equals 71.4 degrees. Side C equals 10.7. Love it. Side A equals approximately 3.6 centimeters. I'll put it in a box just because that makes it really visible. Beautiful. Anyone notice why? Does anyone know why there's a C here and an A here? Did your teacher teach you maybe how to label triangles last year? Luke?
Yes, because they're opposite from the big one.
Yeah, in case that was not taught to you, let's look at that, okay? Because maybe it wasn't looked at in grade 10. It's not sort of necessary until you get to grade 11. So let's say we have any random triangle. And this triangle is called SLY. Just so happens. All right. Which letters do you use to show the angle? Like we're using uppercase for the angles. Okay? Uppercase S, uppercase L, uppercase Y for the angles at the vertices. Which letters do we use for the sides? It's going to be lowercase, and watch this. You write them opposite from their angle. So the corresponding side to angle L is here. I'm just going to write cursive L so it doesn't look like an I. The corresponding side to angle Y is opposite of it. And the corresponding side to angle S is opposite from it. This is how we label triangles. We good? All right. So let's take a look at, let's solve another triangle. Solve angle DEF using only primary trig ratios. Primary trig ratio is SOHCAHTOA, right? There are more. There is cosecant, cotangent, and one more. Those are secondary. So primary are the ones we know so far. Round to one decimal place. All right. So in this case, I cannot use the sum of angles because I don't have that information. So we need to solve for angle D, angle F, and the hypotenuse. Okay, I must start with an angle because it's impossible to solve for the hypotenuse without an angle. So let's start off by finding angle D. So if I want to find angle D, I circle that, and then I label the triangle based on angle D. This is my opposite, this is my adjacent, this is my hypotenuse. Okay, I'm going to circle the other pieces of information that I have. I have O and A. So which trig ratio will I use? Tan, because of TOA, right? So to solve for D, I'm going to use TOA. And that gives me that tan of angle D equals opposite, so 7.4, over adjacent, 6.5. I'm not showing units here because they're both centimeters. And so what must I do? What must I use?
Tan negative 1.
That's, yeah. Yes, we don't, thank you. Beautiful. We're going to use the inverse tan function. And we can see, oh, this angle, this ratio is actually greater than 1. Okay. And that tells me that my angle is going to be greater than 45 degrees because the ratio is greater than 1. What is the angle?
48.
Oh, that was close. Now, don't forget to write degrees. That is a unit.
Is it approximately or is
Thank you. It is. It's always approximate. If you round it, it's always approximate. Okay, now that I have that angle, I can easily find angle F using the sum of angles, right? You're allowed to use sum of angles if you have enough. So angle F is going to be 180 degrees, subtract 90, subtract 48.7 degrees. And because we're using approximated values, we've got the approximated equal sign, right? 48.7 is a rounded number. So what we're saying is, I know I'm not giving you the exact number. How's the game going, Greg? You winning? Oh, good. Good. Okay.
41 or 30?
That's right. 41.3 degrees. Now, I don't have to use the angle symbol every time because by using uppercase letters, I'm telling you I'm finding an angle. All right, and what is left for me is to find the length of the hypotenuse. Okay, so at this point, I'm going to choose either O or A. I don't need to use both. Which one do you want to use? O, excellent. Okay, we'll circle the H because that's what we need to find. Okay, and so are we using sine or cosine? You got sine? Go ahead and use sine to find the hypotenuse.
So if I change this to like, let's say 3.5, so I multiply this into
That I can't say. The one thing I'll say is you don't have any x's there. I don't know if that's on purpose or.
that's just like see.
Got it. Yeah. I can't tell you that. So I've got sine 48.7 degrees equals opposite 7.4 over letter E. Ooh, didn't we just talk about what's the quick way to isolate letter E? What do we do? Swap-a-rucci. Swap. Great. So I know that E is 7.4 divided by sine 48.7 degrees. And it better be bigger than what? Nah. Yeah. So what is it 100% have to be bigger than? Nope. What are we solving for?
9.8. That's even bigger than 7.4.
It's got to be bigger than 7.4. Okay? This is called critical thinking. When you're thinking about what kind of answer to expect, it's got to be bigger than both sides, so it has to be bigger than 7.4. What? 9.9 approximately centimeters. And then at the end, we make our nice statement. Therefore, D equals 48.7. One moment. Lisa, I'll be there. Put a nice box around it. Is the triangle solved? Yes, it's solved. All right, I want you to read the next question. Read it, highlight it, see if you can add anything to the picture. Try to understand what's going on. Yeah, it is. You're saying that the virus goes faster. How many times faster? Is it twice as fast? 10 times as fast? Okay, that's what you need just to get under control. Yeah.
On this slide.
Yes.
I
A fraction. Yeah. Then there's a thing you can press. Swap it. I wonder if it's empty. No. There is a button that you will have here that allows you to go. It's either FD or RP or this one that allows you to move between them. You need to. You're obviously going to need to figure that out. All right, folks, get up. Time for some movement. Yes. That's right. That's right. That's right. And a 1, and a 2, a 1, 2, 3. All right. So what I want you to do, this is a really boring aerobics exercise. Liam, you are invited to join our aerobics exercise. Whoa. All right. I want you to do this. Okay. With one arm, show me an angle of elevation. Oh, you're geniuses. Okay. Now, is it like, yeah, so this here is your angle of elevation. Go back to normal. Horizontal. Show me an angle of depression. Okay. Right? And it's between, this is the tricky thing where people really get mixed up. the angle is always related to the horizontal. So angle of elevation is between the horizontal and my other arm. Angle of depression is between the horizontal and my other arm. Got it? Excellent. Sit down. That was a good little stretch, wasn't it? Do you feel cheated that it wasn't enough? I know. All right. So in this diagram, you can see the angle of elevation and depression. Always, let's write that down. Always from horizontal. So you always measure the angle of elevation and depression from the horizontal line. All right, so let's try a word problem with this. George looks out from the CN Tower observation deck, right? So it's at that second bubble. I don't know who's been to that one, but there's a second bubble up there, okay? George is sitting there, and he sees his house far, far away at an angle of depression of 10.5. A sign beside him tells him that he's 447 meters above ground. How far is his house from CN Tower? All right, folks, watch out. Okay? Who did this?
That's wrong.
Love it. Why, Marley, is that wrong?
Because it's based on the horizontal. Yep.
It has to go from the horizontal. Now, not here, because George isn't here. George is here. We can draw a horizontal. And we can say, oh, this is the angle of depression. This angle here is 10.5 degrees. Now, we've got two options of how to bring that angle into the triangle. Does anyone remember the parallel line theorems? Yeah.
If it's the opposite, it has to equal up to 90 or something.
Okay, so that's one way. One is to say both of these angles are 90 degrees. The second, so this angle here is going to be 90 minus 10.5. How do I find out this angle? How can I use that? Yeah. Do you remember the Z pattern? The parallel line theorem's Z pattern. So the two angles inside the Z are identical, right? So that means that these two angles are 10.5. That's a little easier than doing subtraction. So that's what I'm going to go with. Oh, so this angle is 10.5 degrees based on the parallel line theorem Z pattern. Remember, there was a C, a Z, and an F? Yeah, there was a C. All right. So let's redraw this triangle that we have. So we understand what's going on. Now, please draw the right angles. That's an important piece of information. In this triangle, we know that this angle is 10.5 degrees. We also have been given the height of where George is. George is 447 meters above ground. Right? So the tip of the triangle is where George is. And we are asked to solve for how far away is his house. Do we have enough information? So I count. Do I have 3 pieces of information? Right angle, second angle, 447. I've got 3 pieces of information. How do we solve this? First, we're going to circle what we have and what we need. I've got this angle. I've got this side. And I need this one. Oh, I forgot to label. Then I label the triangle based on the angle that is given to me. So if this is my angle, this is my opposite side, hypotenuse side, adjacent side. How will I solve? Tangent, yeah, TOA, right? I'm using tangent because I've circled O and A. So I've got that tangent of 10.5 degrees equals opposite 447 over adjacent. Ooh, what can I do? It's time for a fun swapperoochie. Folks, before you calculate it, are you expecting your answer to be greater than or less than 447? Look at your triangle.
I'd say greater.
Okay, let's see. These predictions are really helpful. Anyone got a number for me? 2,411. Did they didn't? So let's keep it to no decimal places. So 0.11 or 12. Sorry, 11 or 12. Therefore, his house is, I'm just going to say 2.4 kilometers away. Who had a question? All right, read the next question. It is tricky, and I love putting it on the quiz. Yeah. Well, I said nearest 100, so 2 decimal places. Yeah.
And also, for this question, I just
Yeah, it's a one-step thing. You're good? All right. You're welcome. All right. How fun does this one look? Not very fun. All right, let's take a look. We've got our Earth. We are told that we are looking to find the length of the 49th parallel of latitude. So we're looking to find this at 49 degrees. We are given that the radius of the Earth is this distance. Now, folks, remember that the radius is the distance from the center of the circle to any point on the edge of the circle. So that means this here is 6,380 kilometers.
It's okay if you write on the other side.
Pardon?
It's okay if you write like 680 on the opposite side of the line.
This one?
No, like this one. It's okay.
I think it's okay. All right. Also, if it's the 49th parallel, what that means is that the line, the radius reaching that latitude makes an angle of elevation to the equator of 49 degrees. This is the key feature that you need to remember when you get this question on the quiz. that if it's the 49th latitude, it means it makes an angle of elevation between the radius and the equator. All right. Now, we are looking for the three-dimensional length of the 49th latitude, right? So in order to find the length, we must find the circumference. And the formula for the circumference is 2 pi r. Okay, so we need to find the radius at the 49th parallel. Luckily, this is what we're looking for. Right? The radius is half the length of a circle across. So we're just looking to solve for that x. And we've got a right angle triangle. So let's see what we've got for this triangle. Let's redraw it. I know I have a right angle. I know the distance of the hypotenuse. And I know that one of the angles is 49 degrees. Is it the top angle or the lower angle? Think about the Z pattern, right? So Z means that the top angle is also going to be 49 degrees. Beautiful. And let's put an X where we want to find this distance. That's my X. That's what I want to solve for. So step one, I'm just going to circle what I have and what I need. I've got this angle, got this, and I've got that. Oh, and I keep forgetting to label it. Let's label OAH based on the 49 degrees. This is opposite, adjacent, and hypotenuse. So I'm going to use which ratio? I'm going to use cosine. So cos of 49 degrees equals adjacent over hypotenuse. I multiply both sides by 6,800 or 6,380. Let's use whole numbers, so no decimals. Give me the estimate that we have. What'd you get, Elian? 4,986. Okay, what are we talking about? Beautiful. Just let's keep in mind what we're talking about. Okay, so we found, so this is the radius at 49th parallel. Okay, so we just found the radius at the 49th parallel. And so if we're asked to find the length of that latitude, we need to find the circumference. And that is 2 times pi times the radius we found, 4,186. So we get an approximate answer so 3.14 is very grade 9. You need to use your pi button. So you need a new calculator. Or you need to find it. I am sure it is there. Oh, good. It is there. Okay.
Miss, I went to multiply 2 by pi number, then multiply by...
Yeah, 26,301. That's how long. So if you were to drive around the world on the 49th parallel, you'd be driving 26,000 kilometers. All right, let's crunch it. Last question. I want to go to the next one. All right, last question. Solve for angle theta. So in this triangle, it might be helpful to have some letters. I'm going to call it A, B, C, and this vertex right here is going to be vertex D. Vertex is where two lines meet. So we've got 3 triangles in there, but we only have 2 right angle triangles. And because we don't know how to use sine and cosine law yet, we cannot. We must use the primary trig ratios. So to find angle theta, we're going to need to, so we have 2, so if we look at our triangle ACB, A, B, or wait, take a pause. Thoughts about how I do it? Yeah, Greg? Good. So watch this. Angle theta is going to be angle CAB subtract angle DAB. I want you to look at how I wrote that and if it makes sense. Right? When we have 2 triangles, we can't just say angle A because there are 3 different versions of angle A there. So I need to give it a name showing all 3 vertices. Yeah.
But isn't it just going to equal 0 because they both have to add up to 180?
No, because we're talking about 2 different triangles. Okay. How are we for time? I hate rushing like this. Should I rush it or should I do it tomorrow? All right, but I do want you. Yeah. Okay, we'll do this tomorrow morning. All right.
I'm sorry, but tomorrow is Wednesday.
Oh, okay. Maybe not tomorrow. Maybe on Monday. Okay. Folks, have a good weekend.